thanks, James, for that talk there. Before we actually get into the demo, let's quickly go over what's installed on the clusters of when you're using Tongzu application platform. So the capabilities of Tongzu application platform will most likely be installed on multiple clusters, and the capabilities that you do install on each cluster will depend, of course, on the role that cluster plays. So the question is what capabilities of the platform will run in the inner and outer loops that James had referenced earlier? And so does everything need to be installed on all of my clusters? If you wanted to, that could definitely be done, and that may be how you start out, but it is not required. And so the inner loop, as you mentioned, is the developer's workspace. And these are your development clusters, and this can be any Kubernetes cluster running locally on your laptop, on vSphere, or of course in the cloud. And the outer loop are your clusters that are used on the path to production. These can also run locally, most likely not locally, but on the cloud or in one of your local vSphere environments. And so the capability to enable each cluster to utilize the same paved path of the supply chain is actually what we call the supply chain choreographer. And so this will be installed on each cluster to utilize the same path to production. So in our demo, we're actually using two clusters. The developer or inner loop cluster is running in GKE, and our ops prod cluster is actually running in EKS. And as you might imagine, the inner loop cluster has just enough enabled for developer to simulate production during coding and testing. And the outer loop cluster has the full installation. The good news is we have profiles during the installation process where we can help have a canned way to install either a full cluster or a developer cluster, or you can actually customize it all the way. All right, so let's get to the demo of where I'm going to start is actually with the developer experience. And a great example of a capability that's not actually on our development cluster is Application Accelerator, which we can get through the tap user interface that you see on my screen now. This is actually running on our cluster in EKS. So I'm going to go to Application Accelerator because I want to start a new project. And Application Accelerator comes with the product and comes with some canned or some pre-made application accelerators. And I'm going to use one of the pre-canned one called Spring Sensors that you see here. And then I'm going to choose it. And so this application accelerator, you can think of it as a templating engine to start a project. And so if you're not familiar, it's used to create ready-made enterprise conformant code and configuration. So I selected Spring Sensors here, and this is where you can make some changes to the code that you're running. We're not going to make any changes for this demo, but this is where it would be done. But we can see what's behind this accelerator and explore these files, which actually live in a Git repo. You can see this project has source files for Java, also some Maven files, and this is all you'll need to get started on this project. One of the key files of this accelerator is the workload file, and the goal here is this will be the only YAML file that the developer should actually have to use to build and deploy their application to their inner loop cluster. We'll go into more details about that file when we actually get to the deployment. But for now, just know it's part of the accelerator. And to utilize that, we just hit next step, create, and it will download a zip file for us. So the zip file gets downloaded. You're going to copy it locally, and then you'll open up your IDE. Right? And as a developer, I would love to stay in my IDE for as much as possible while I'm coding and testing. And since this application will ultimately be running on Kubernetes, I would also love a way to easily run in Kubernetes while I'm coding in a live fashion. And with Tanzu Application Platform, we'll be able to do that here right in the IDE. So let's check out, we'll do a couple commands here down on the bottom of the screen. Let's see, make sure we got, nothing running at this time. And my application will be running on localhost 8080 when I get it going. So just making sure nothing is running here to start. Okay, So back to our IDE. So nothing's running in Kubernetes, but I want to run my source code that I had just downloaded. So there's a tilt file. So we use an open source product tilt to actually make this happen within my IDE here. So I just right click on this tilt file and you see a couple options down here at the bottom, live update start and live update start and stop. And so I'll select start. And what you'll see here on my message screen is a bunch of logs that you probably won't be able to read, but this is the supply chain starting to take action on this workload. And so part of my supply chain is the build of the container, which will be done with Tanzu build service. It'll push it to my GCR registry and it'll actually deploy it onto my Kubernetes cluster. So this will take a couple minutes. And while this is happening, we'll go a little bit over more of the details of the workload file. So how does a workload get picked up by a supply chain? And right now it's done by labels. So you see this label here that I have highlighted that will actually, the supply chain that has that corresponding label will actually pick up this workload and go through the process of the supply chain. And the source code is pretty, I changed this from the Accelerator, but that's the source code that we're using. And the other cool thing that is in this example workload file is the service claims. So our application Spring Sensors, it uses Rabbit, and I have a Rabbit MQ installed on my cluster. And what this service claim will do is automatically configure my pods to use that Rabbit that's on my cluster. So you don't have to do anything as far as setting up environment variables in your deployments or anything like that. It will all be done, taken care of for you. Quickly, while we're still waiting here, we can list our workloads again right here and see it's still running. We can also do the logs here, which is pretty close to what we see on this other screen running right now, on this other terminal, sorry. So we'll stop that and do a couple of Kubernetes commands to see, you see this build pod that's running this. So that's actually the pod that was called by the supply chain to build my container.
Hey, Aaron, we got a question in. Maybe we can ask this while we're waiting for the build to continue to come through.
Yeah,
one of these questions are, is this based on Spotify's Backpage?
The GUI, the tap GUI that I saw, the interface that you saw, that is, this is based off of Backstage.
Okay, perfect. Thank you.
All right, so it usually takes 2 minutes. You can see the build is successful down here. If I do a watch command here, we can sort of watch what's going on. So the build has completed, so very shortly we should see some pods get started up. So while we're waiting, I don't know if there's any other questions there.
We have quite a few questions here, Aaron. I think we can just ask maybe one more right here. Who uses Tongzu application platform?
Yeah, I mean, I can answer it from the developer's perspective. The developer will use the tooling of the platform. So in this case, we have Visual Studio running with the Tongzu application extension, which enables you to use this workload YAML file as your only file, right? So you don't have to have a Docker file. You don't have to have a bunch of Kubernetes YAML to deploy this and test out your code. And then what we'll see here is the developer being able to make live changes on that container as well. For the ops side, Tongzu application platform will be used by the ops teams to configure different steps along the process, sort of choreograph what is already the tooling that you already have, for security, scanning, building the images, pushing it out, and then anything else that could be done on a supply chain to get this code to production. So I have 2 pods running here. I'm actually waiting for this third one here to start up, because that will be the main pod. Let's go ahead. Oops. That's pretty similar. You can see this receive sensor data message. That'll be important here in a second. But let's go check out our application to see if it's actually up and running. Cool. So we have a Tanzu sensor database up and running. But as a developer, I want to make some changes, obviously, here. And I want to do it live in that cluster while I'm doing my coding. So I want some more information to be logged here. So the first thing I'm going to do is uncomment these log files that I have pre-made here. And then I also want to change the title a little bit and say Tanzu weather sensor. So I have two files that I've changed, and I want to actually see this running. So all I have to do is save all these files, and then we'll start to see my container will actually restart, and the tilt and the live update that we're using, Tongzu live update, it's actually going to update the jar on the running container. So once we see our new messages, we'll know that the changes have been put out there. And you can see right here, the ID, pressure, temperature data is showing up live. And if we go to our website here, or our page here, our local host, you can see that weather is now there as well. So that is showing the developer experience doing live updates while you're coding. I think it's pretty cool. And so one thing you may have noticed is the command line wasn't used to deploy, right? All I did was right click that file and say Tanzu live update. And it kicked off everything based off of that workload file that's tied to a supply chain. And that is the superior developer experience we're aiming for here. So at this point, my code is ready for check-in and it's path to production. So I'm going to hand it off to Ryan so we can see what happens next.